Hi Lily, I hope you're doing well. Today I'll be explaining how I work through the fashion MNES assignment. I used the Keras library to create a neural network model that classifies images of clothing items. Here I imported the required libraries. I import the fashion MNES dataset from Keras, which provides a preloaded version of dataset. And then I loaded the data using the load data function from Keras. It returns 4 variables: train image, train labels, test image, and test labels. And then it asks us to print the dimension of train image, train labels, test image, and test labels. We printed the shapes of these to see how many image and labels are in each set. Here train image shape 60,000, 28, 28. It means that there are 60,000 image and each image is 28 pixels. The test images are similar with the 10,000 images, and both the labels have shapes of 60,000 and 10,000 for the training and test labels respectively. And here we printed the lengths of train labels and test labels, 60,000, 10,000. And number 3, we please print show some of the train and test labels. We printed the first 10 labels from the training and testing data set. These are the numbers that corresponds to different clothing types in the function MNES data set. And here, by using I am sure, I plotted the image at index 5 from the training to see what it looks like. And number 5, again I'm plotting the image from index 5. This time I'm just showing the image itself with no extra detail. And number 6, here I wanted to check what label corresponds to the image at index 5. By looking up the label, I can identify which clothing item this image represents. And here number 7, I'm doing the same thing but with an image from the test data set. I'm showing the image at index 500. Here I'm just plotting the image at index 500 from the test data set to confirm that the data is displayed properly. And here I also check the label for the image at index 500 in the test data set, just like I did for the training test. And number 10, it asks us to import models and layers from the Keras library, which we already did. We define the sequential model and call it my network. Here we reshape the image from 28 to one column with 84 neurons. We normalize the image by dividing the image by 255, and we add one hidden layer that has 512 neurons using the ReLU activation function. Number 15, we add another hidden layer that has 128 neurons using the ReLU activation function. Number 16, we add the next layer as a neuron dense layer that uses the softmax as the activation function. We explained here for softmax. And number 17, this settings allows me to experiment and see how different optimizers and loss functions affects the model's performance. And here number 18, these settings here this helps me the model learn and adjust its weight during each epoch to minimize the error. And then number 19, it asks how do you compare the fashion MNES with what we learned in the class using the MNES explaining video. In class we work with the MNES dataset, which contains handwritten digits. The fashion MNES dataset is similar, but instead of numbers it contains images of clothing items. This makes the task a little more challenging because clothing images are more complex. And number 20, what we can infer from the difference in the accuracy. What could be the reasons for that? The accuracy might be lower on fashion MNES compared to MNES because clothing image have more variety and details, while digits are more consistent. Factors like image complexity and class balance can affect accuracy. And finally, I use the evaluate function to check the model's performance on the test data. If the accuracy is much higher on the training set than on the test set, it means the model might be overfitting, which is when the model learns the training data too well and struggle with the new data. And that was all my code. Thank you.